First section of notes today is titled Solving Rational Equations. Question for this section is 9 over 28 plus 3 over y plus 2 equals 3 over 4. To solve this rational equation, we need all the denominators to be the same. For example, if this one's 28, we can change this one to 28 by multiplying by 7. This middle fraction also has to have 28 also, as just a coefficient number. So we'll have to multiply that one by 28. Also, this fraction has a factor of y plus 2, which means each fraction has to have a factor of y plus 2. From here we can multiply, distribute out, and combine the fractions. For example, 9 times y plus 2 would be 9y plus 18. 28 times 3 would be 84. And 3 times 7 would be 21. And we can distribute this 21 to 21y plus 42. The fraction on each of these is the same. It would be 28y plus 2, 28y plus 2, and 28y plus 2. All the fractions have the same denominator and they're all equal. So what we can do is cross off those denominators or ignore them and just solve the top equation. 9y would come down. 18 plus 84 would be 102. 21y plus 42 would come down. We can subtract 21y on both sides. It would be negative 12y. We can subtract 102 on both sides, which would be negative 60. And we can divide by negative 12. And the answer would be y equals 5. The next section of notes is titled Elimination of Possible Solutions. First question is x plus x squared minus 5 over x squared minus 1 equals x squared plus x plus 2 over x plus 1. Same idea as before. We have three terms or three fractions. Before we can add or subtract the fractions, they have to have the same denominators. In this case, one of the denominator's factors, x squared minus 1, is the same as x plus 1, x minus 1. So in this case, these two fractions have x plus 1, which means this first term x also has to have a x plus 1. The second fraction also has a x minus 1 in the denominator, so this first fraction has to have x minus 1, and the second fraction has to have x minus 1. We did multiply by x plus 1 on the bottom of this fraction, so we'll have to multiply by x plus 1 in the numerator and also x minus 1 in the numerator. This fraction we multiply by x minus 1, so we have to multiply the numerator by x minus 1. The second fraction we did not multiply anything, so x squared minus 5 would stay the same. Multiplying these out, x minus 1, x plus 1, that's the same as x squared minus 1. And then we're multiplying by x. And the denominator is x plus 1, x minus 1. The second fraction did not change, x squared minus 5. We'll leave the denominator in factored form, x plus 1, x minus 1. And the second fraction, we can begin to multiply this out. This x will be distributed to each of these terms, which would be x times x squared, x times x, and x times 2. We'll also have negative 1 times each of these three terms, so that would be a negative x squared, a negative x, and negative 2. This 2 up here is actually 2 times x, so that should be 2x. That's the numerator, so the denominator again should be x plus 1, x minus 1. Again, once all your denominators are the same, you can cross those off or ignore them for now. At the end of the problem, we'll get back to the elimination of possible solutions, which will look at the denominators. This numerator we can distribute, x times each of these. That'd be x cubed minus x. X squared minus 5 stays the same. Equals, we have x cubed. The x squareds actually cancel out, positive x squared and negative x squared. 2x minus x would just be 1x or plus x, and minus 2 on the end. Solving this equation, the x cubes cancel by subtracting on both sides. And then we're left with x and x squared. So what we'll want to do is bring everything to one side and then see if it factors. So we can subtract the x over and add the 2. We'll put x squared first. Negative x minus x would be negative 2x, and negative 5 plus 2 would be negative 3. Nothing left on the right side, so that would equal 0. When we're left with x squared and x, you want to check and see if it factors. In this case, it would factor to x minus 3 and x plus 1. From here we can solve, get our two answers, x minus 3 equals 0 and x plus 1 equals 0. Add 3 to both sides, x equals 3. Subtract 1 on both sides, x equals negative 1. These are two answers. In this case, these are two possible answers. What we have to do is look back at the denominators that we canceled out. If you remember, anytime a denominator is equal to 0, it's undefined, and undefined would be no solution for that question. If we have a 3, x equals 3, 3 would be okay in each of these denominators. But if you plug a negative 1 in to this first denominator, negative 1 plus 1 would be 0, and the denominator would equal to 0, which would make this question undefined. If you have any answers that give you 0 denominators or undefined, we're going to cross those off and eliminate them as a possible solution. So instead of 2 answers, this question only has 1 answer, x equals 3. And again, to check those, plug them back in. If any of the denominators equal to 0 in the original question or the factored questions, then you can cross off the answer that makes it 0, and the ones that are left are the only possible answers. Title of the next section is Solving Rational Inequalities. In this section, we'll solve rational inequalities and check for possible solutions. First question, and only question for the section. 1 over 4a plus 5 over 8a is greater than 1/2. Solving the inequality, or rational inequality, which has fractions, we first want to get common denominators. Looking at the numbers or coefficients 4, 8, and 2, the common coefficient or common number would be 8. So the first fraction we can multiply by 2 in the numerator and denominator, and the last fraction we can multiply by 4 in the denominator and numerator. The first 2 fractions also have the variable a in the denominator, so the last fraction will multiply by a also. So our common denominator would be 8a. Multiplying, the first fraction would be 2 over 8a, plus the second fraction would stay the same, 5 over 8a is greater than 4a over 8a. Again, when we have fractions in an inequality, similar to an equation, once the denominators are all the same, we can cross those off or ignore those for now, and then solve the numerator part of the inequality. We'll have 2 plus 5 is greater than 4a. Combining like terms, we'll have 7 is greater than 4a, and solving for a, we can divide by 4. So we'll have 7/4 is greater than a, or if you rewrite the inequality, a will be less than 7/4. Similar to equations, we want to check for possible solutions. When we have an inequality, we'll look back at the numerator, or the denominator we crossed off, which was 8a. 8a again cannot be equal to 0. If it's equal to 0, then the entire equation or inequality would be undefined. So if we divide both sides by 8, we'll have a equals 0, which is not a possible solution for this inequality. Once you have the possible answer to the inequality, as well as answers that can be eliminated, what we want to do is look at a number line to eliminate any other possible solutions. For example, the 0 we put on a number line, and 7/4 we put on a number line. Separating the number line from 0 and 7/4, we'll have 3 sections. The first section is all the numbers less than 0. The middle section is the numbers between 0 and 7/4, and the last section is all the numbers on the right. What we want to do is pick a number from each section, plug it into the original inequality, and see which of these sections will work. For example, looking at the number 0, we can take a number to the left of 0, which would be -1. We'll plug a -1 into the original inequality. If -1 works, that means all the numbers less than 0 will be a solution. If -1 does not work, that means none of the numbers less than 0 will be a solution. The original inequality was 1 over 4a. or if we multiply by -1, that would be -1/4, plus 5a, but if we multiply by -1, that would be -5/8 is greater than 1/2. Simplifying this, or getting common denominators, we can change the first fraction into -2/8 minus 5/8 is greater than 1/2 is the same as 4/8. -2 minus 5 would be -7/8 is greater than 4/8. This inequality is false since a negative number, or -7/8, is not greater than 4/8. So looking back at our number line, the left hand side we can cross off, which means none of the numbers less than 0 will work for this solution. Our middle section, numbers between 0 and 7/4, and again we can pick any number. Nice number to pick would be the number 1. Our original equation again, 1/4a, or if plugging in a 1 would be 1/4, plus 5/8a, 5/8 would stay the same, is greater than 1/2. And again, if this is a solution, then all the numbers between 0 and 7/4 work. If it's not, then none of the numbers between 0 and 7/4 will work. Getting common denominators again. 1/4 is the same as 2/8, plus 5/8, and 1/2 would be 4/8. Adding the fractions, we'll have 7/8 is greater than 4/8. 7/8 is greater than 4/8, which means in our solution we can circle the numbers between 0 and 7/4, which will work as solutions. And the last section, numbers bigger than 7/4. We can pick any number that is greater than 7/4. The next whole number that we could use would be 2. Plugging a 2 into the original equation, we'll have 1/4a, or 4 times 2, which would be 1/8, plus 5/8 times 2, which would be 16, is greater than 1/2. Getting common denominators again, the first fraction would be 2/16, plus 5/16 is greater than, changing 1/2 into 8/16. Adding the fractions, we'll have 7/16 is greater than 8/16. 7/16 is not greater than 8/16, which again means the section with 2, or the right hand section, does not work for the inequality. The only section that works is the number between 0 and 7/4. So writing our answer as an inequality, we'll have 0 is less than, our variable a is less than 7/4. So any number between 0 and 7/4 is a solution. All the other numbers are not a solution.